Good morning, dear students. My name is Radheshyam, and we are discussing error analysis. So we have discussed that in every measurement there is always some error, because all measurements essentially have these four constituent part, or you can say these four factors in every measurement. That is, there will be an instrument, a procedure to take the measurement, and there will be an observer or a person who will be taking reading, and then there is environment under which this experiment is carried out. And because of these factors, there is uncertainty in the measurement, or there is error in the measurement. So now we want to classify what kind of errors are there. So we say that there are two types of error. Grossly, or you can say mainly, there are two types of instrument, two types of error. First is, or one of them is called systematic error. Systematic error tend to be in one direction. In systematic error, or you can say the error that is tend to be in one direction. This means that zero positive error or zero negative error tend to be in one direction. We are saying that systematic error tend to be in one direction. And further, systematic error is divided in these. Systematic error are caused due to instrumental error. Instruments are there, and because of the, now suppose that our instrument, we have taken a normal scale, and readings are graduated like this. So if you measure from this point, if you are careless and you are measuring from this point, then you are essentially measuring this much extra value. So this is called zero positive error. Or we have a scale that is worn off. So zero is, or you can say that 0 or 1, so you can see that this part is worn off. So whatever we are measuring from this instrument, it will be always less than the expected value. This is called negative zero error. So because of this, instrumental error, negative zero error. So we are saying that in systematic error tend to be in one direction. So whenever you are using instrument that are faulty, or you can say worn off, or some graduation marking error, because of that there will be always this much of error, negative error, or there will be positive error, positive zero error. This is called positive zero error, this is called negative zero error. So you can see that there will be always some error because of faulty instrument. Or also we can have the instrument that they are less precise, so that will also give error. And after that, we are saying that there is procedural error. So now suppose that we are measuring body temperature. So if we put thermometer in the armpit, so it will give less temperature compared to the actual body temperature, which is more. So we need to have a better procedure to take body temperature. And after that, there could be personal error or personal bias. So whenever a user is taking this reading, he may have proclivity to take measurement from a side of zero. So instead of taking the value directly from top of the meter, he can take values from side. So there will be always parallax. It's called parallax error. So if user is not careful, then there will be always error because of person or the user who is taking reading. After that, we are saying that second type of error is random error. In this, this error is random in nature. This is not systematic. This is random in nature. So we do not know what is the reason because of which this error come in the picture. So there could be change in voltage fluctuation, or some vibration, or some impulsive force, or some humidity, or rise of temperature. So these kinds of uncertainty, which are totally random in nature, which we do not have any control to correct. So systematic error tend to be in one direction. So we usually can make some improvement in this systematic error by taking the good instrument, good procedure, and the person who is taking reading to be more alert. So we can minimize this systematic error. But a random error, because this is random in nature and both size and size, this is hardly manageable. This least count error occur because of instrument. A least count that could be measured. Least count means what is the smallest value that we can measure from an instrument that could be measured. We are saying that least count error occurs because of instrument. Why? Because least count is the smallest value that could be measured by any instrument. So you can understand that all instruments have this limitation, least count limitation. It cannot measure less than this value, least count value. So in case of vernier calipers, we can measure 0.01 centimeter. So this is the smallest value that can be measured from the vernier calipers. So this much of error will be always there, and this least count, so all instruments have this least count, and because of that there will be always a least count error, because you cannot measure more accurately than least count. So least count error will be always there. And this is random in nature. This occur in both systematic error and in random error. This occur in both systematic error and random error. So hopefully this helps you